Today I will be talking about significant figures, and that is the total number of digits recorded for a measurement. And these digits can be recorded by scales or any other kind of measurement tools. To calculate how many significant numbers a value has, we first need to know some rules. The first thing to know is that zeros in the middle of the number are always significant. So for example, this first number here, 5.903, has 4 significant numbers, including that 0 in between the 9 and the 3. The second as well has 3 significant numbers, and that 0 is significant. In 3.09, the 0 is also significant, and it has 3 total significant figures. The second thing to note is that zeros in the beginning of the number are not significant. So the numbers that are not significant, I've highlighted in red, and the numbers that are significant are highlighted in green. So if any zeros come before the first non-zero number, in the first case it's a 3, they are not significant. In the second case, we have 2 zeros that come before the first non-zero number, that is again 3. So that means that these 2 zeros at the beginning are not significant. And in the last example here, we have all of these zeros coming before a non-zero number. So therefore, it doesn't matter how many zeros there are in front, they're all not significant because they come before the first non-zero number, that is 2. So the next note is that zeros at the end of a number and after the decimal point are always significant. So in this case, in the first case, we have 8.9900. So these last 2 zeros, they are significant. So just note that if they put zeros after the decimal point, it's meant to be there. Therefore, they are significant. So that's why at the end of the numbers, they are significant, but before the numbers, they're not. For the second example, this has 3 significant numbers, and 2 of them are zeros that come after the decimal point. And then in the third example, we see the second note and the third note being put together. So any zeros that come before the first non-zero number are not significant, but any zeros that come after the decimal place are significant. So these last 2 zeros are significant, but the first 3 zeros are not significant. Therefore, this number has a total of 5 significant numbers. The last thing to note is that zeros at the end of a number and before the decimal place may or may not be significant. So for the first example, we have 52,000. So these 3 zeros here may or may not be significant. We have no idea how to tell if they are significant. This number it has 2 for sure significant numbers, but it can have at least 2, or it can have 3, or it can have 4, or 5 significant numbers. We don't know. For the second one, these 3 zeros here may or may not be significant. Therefore, this number has at least 3 significant numbers, being the first 3 numbers, 4, 5, or 6 significant numbers. And for the last one, the very last 0 here may or may not be significant. Remember that zeros in the middle of a number are always significant. That's why this 0 here is significant. So we have at least 3 significant numbers, but we could have 4. And the reason why we say it may or may not be significant is because we don't know what scale they used. So the scale that the reader used to record these measurements would have to be determined to know if these zeros are or are not significant. But since we're not given that, we just say that it can have however many significant figures. So now we'll move on to the next slide, and that's going to be using significant figures during calculations. So this is when we'll talk about multiplying, dividing, and adding and subtracting. So the first examples occur when you're multiplying and dividing. And when you are multiplying and dividing, you want to use the least number of significant figures for your final answer. So for example, in the first problem, we have 5.63 divided by 7.1. So 5.63 has 3 significant numbers, and 7.1 has 2 significant numbers. So our final answer, we want to have the least significant figures. So that's going to be 2. Your final answer should be 0.79. So for our next problem, we see that our first value has 3 significant figures, and our second value has 2 significant figures. So again, our final answer should have 2 significant figures. This will give us the answer of 27. In our last problem, we have 3 significant figures for the first value, and then we have 5 significant figures for the second value. Remember that zeros after the decimal place are significant, so these 2 last zeros do count as a significant figure. So we want to use the least number of significant figures in our final answer. So our answer will be 34.8. And that will be 3 significant figures. And I made a note here saying that use all the digits for the calculation, whether significant or not, then round off the answer. So for example, in this first problem where we have this 5.63 divided by 7.1, even though I know my final answer is only going to have 2 significant figures, I don't want to round off the 5.63 to 5.6. You want to make sure whenever you're doing the calculations in your calculator, you take the full number, and then at the end you use the appropriate amount of significant figures. So now we'll move on to adding and subtracting. And when you're adding or subtracting, you want to make sure you use the least number of digits to the right of the decimal place. So for example, in 0.518, we have 3 digits to the right of the decimal place. And in 5.1, we have 1 digit to the right of the decimal place. Therefore, when we add these two numbers, our final answer should have 1 digit to the right of the decimal place. This will give us 5.6. In the second problem, we have 3 digits to the right of the decimal place in the first value, and in the second value, we have 5 digits to the right of the decimal. Even though this 0 here is considered not significant, we're no longer talking about numbers being significant. We're talking about digits to the right of the decimal place, whether or not they are significant. So our final answer should have 3 digits to the right of the decimal place. And this answer should be 95.431. So now I'll move on to the next slide. So these last 3 problems ask how many significant figures are contained in the final answer. So we first see that we have a multiplication going on, and whenever we're multiplying or dividing, we want to use the least number of significant figures for the answer. So 5.00 has 3 significant figures. Remember that any zeros that come after the decimal place are significant. And 8.2 has 2 significant figures. So when we multiply these two numbers, we should have 2 significant figures. And this will give us 41 exactly. And now we're going to add 6.9 to this. And now when we're adding, we want to use the least number of digits to the right of the decimal place. So in 41, we have 0 digits to the right of the decimal place. Remember that there's an implied decimal place here, yet there's no numbers to the right of it. And in 6.9, we have 1 digit. So our final answer should have 0 digits to the right of the decimal place, which will give us 48. In the next problem, we have 37.2 minus 28.5. And when we're subtracting, we want to use the least number of digits to the right of the decimal place again. And they both have 1 digit to the right of the decimal place. This will give us 8.7. And now we're going to take 8.7 and we're going to divide by 5.56. And when we're dividing, we want to use the least number of significant figures. So 8.7 has 2 significant figures and 5.56 has 3 significant figures. So our final answer should contain 2 significant figures. This will give us 1.6. The question is asking how many significant figures are contained in the final answer. I'm just going to write out to the side the number of significant figures. So I'm just going to abbreviate it sig figs. So you'll hear that a lot, people calling significant figures sig figs. It's just an abbreviation. So 48 has 2 sig figs, and 1.6 also has 2 sig figs. So in the very last problem, we first have 5.78 times 0.0032. And when we're multiplying, we want to use the least number of significant figures. So 5.78 has 3, and 0.0032 has 2. Remember, any zeros that come before the first non-zero number, which in this case is the 3, are not significant. So this number only has 2 significant figures. Therefore, when we multiply these two numbers, our answer should have 2 significant figures. So our answer comes out to be 0.018496. I'm writing this all out because remember that our note up here states that use all digits for the calculation, whether they're significant or not. So I'm just going to make a note that whenever we multiply these two numbers, we want it to have 2 significant figures, which would be here, because these 2 zeros in front are not significant. So now we're going to take a number and add it to another number, and when we're adding, we want to use the least number of digits to the right of the decimal place. So in this case, even though we're using the whole number, we know that because we multiplied it first, we only want these 3 digits to the right of the decimal place to count for the final answer. 3 digits to the right of the decimal place plus 3 digits to the right of the decimal place. Our final answer should have 3 digits to the right of the decimal place. So I'm going to use this whole number, 0.018496, and I'm going to add 0.023. And I know that my final answer should contain 3 digits to the right of the decimal place. This will give me, so this equals 0.041. And this is also 2 sig figs. So this will conclude the topic over significant figures.